Welcome everybody. This is a very popular question that most will get it wrong. Approximately 98% of the people will choose the wrong number as the larger number. Now, I wouldn't say that it is their fault because these two numbers, they look like that. One is a factorial function, the other is a power function. Now, it is imperative to understand that the factorial function, it increases sporadically. Example, say for illustration, let me take the following numbers: 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial. Now 2 factorial is 1 into 2, which is 2. Now 3 factorial, it's 1 into 2 into 3, it's going to be 6. 4 factorial is going to be 1 into 2 into 3 into 4. That's 24. The numbers are manageable. Now 5 factorial, you multiply 5 to this. What do you get? 5 4s are 22, 5 to that 10, 11, 12, 120. Again, it's manageable. Now 6 factorial, immediately it jumps to 720. You multiply by 6, 6 times 2 is 12, 1. 6 4s are 6 and you have a 7 there. Now guess what happens with 7 factorial? You have 3, or I would say 2 numbers in one digit, 2 numbers in or I would say 1 number in 2 digits, and you have 2 numbers in 3 digits. Now 7 factorial, you multiply by 7, what do you get? 7 2s are 14 ones, 49 and 50, 5040. Now guess what happens for 8 factorial? 8 0 are 0, 8 4s are 32, 3, 8 5s are 40. You see that? From 4 digits, you get 5 digit immediately, and next 9 factorial, the digit will augment. So from here onwards, you can clearly see you have 2 one-digit number and a single, or I would say just 1 double-digit number, and then a 3-digit you have 2, and then from then onwards the numbers, they increase erratically. There is no pattern in this at all. That is the case with 9 factorial, or I would say factorial functions. And guess what we got? We got 99 factorial. So we have to handle that a little bit carefully. Now coming to the power concept, clearly 2 squared or 2 raised to the power of 3 or 2 raised to the power of 4 or 2 raised to the power of 5, no matter what the base is, the increase is controlled. In other words, they follow a pattern. So we can literally control this increase, and we will be able to write a predefined algorithm to generate this. It's within our control, because no matter what the base is, we know what's going to be coming for any n with the specific base. So on one side you have a function which is steady. On the other side you got a function which is erratic in behavior. So between these two we need to compare. Of course, you can take your chances. You can outrightly say this number is greater than the number on the right side, or the number on the right side is greater than the number on the left side. But in any situation, they will ask you this question: how do you know? Right? I'll just place it as y. In other words, they might ask you, why do you say this is the larger number, or why do you say this is a larger number? So you will have to give a reason. Reasoning is critical. So that's exactly what I'm going to show you, how to reason this. Now As I mentioned to you, when you say 5 factorial, what does it mean? It means 1 into 2 into 3 into 4 into 5. So when you say 99 factorial, what is the meaning of this? This means you're starting with 1 times 2 times 3 times 4 times 5. All the way you go up to 99. Now the number before 99 is 98. Now what I wish to do is I would like to check the number before 98, that is 97. Now clearly I can group 99 with 1. Of course it's product, but I am trying to group them in such a fashion that when I add 1 to 99 I get 100. As I mentioned that grouping, clearly 98 grouped with 2 will give me 100. Of course it's product, but I'm just taking this as a logic. And similarly 97 with 3 we or I would say 97 with 3 is over here. 97 with 3 is 100. Similarly 96 with 4 is 100 and 95 with 5 is 100. So we can group them in couples. Okay, product multiple, product multiple, product multiple, and so on and so forth. So my question is, how many such grouping is possible? Right? In other words, I am actually interested in the number which cannot be grouped, which is left out from the grouping. Okay, so over here is going to be 1 multiplied with 99, over here is going to be 2 multiplied with 98, over here 3 multiplied with 97, 4 multiplied with 96, over here 5 multiplied with 95. So you have a group here which when added gives me 100, similarly 100, 100 and so on and so forth, it goes off. Now definitely there will be one particular number which is left out. Okay, so we want to get that number without a couple. How do you get that? Now you see the last number, you take the last number, you add 1 to it and you divide by 2. What do you get? 50. So 50 is the number that is left out. Okay, so all these numbers have to be product multiplied with 50. Okay, so much so for that. Next, you see here I have grouped all these numbers. My next question is, how many such couples are there? How many couples are there? So how do you find that out? So what you got to do, you take this number 99. Okay, from 99 you subtract 1 and you divide by 2. What do you get? 98 divided by 2. So what is this? 2 4s are 8 and 49. So 49 such couples are available. So this is term 1, term 2, term 3, term 4, term 5, etc. Up to 49 such terms are present. So those are the valuable insights that would help us to find out the larger number of the two given numbers. So now coming back to our 50 raised to the power of 99. So what is the meaning of this? This means 50 is multiplied with 50 is multiplied with 50 is multiplied with 50 99 times. Okay, this is going on up to 99 such times. Now as I mentioned to you, what I wish to do, I would like to group them. Okay, so that grouping is critical. So how do we group them? So it's going to be first 49 terms, 50 into 50 into 50, etc. 49 terms, and then next 49 terms, 50 into 50, etc. Okay, so this is going to give me totally 98 terms. So there will be 150 that is left out. So let me place that 50 there. Okay, now I group 50 with 50. That is going to give me 50 squared. 50 with next 50. 50 squared. And totally I would get 49 such terms. Okay, 49 terms are here. So let me just write it as 49 terms. And there is going to be 150 that is left out. Okay, fair enough. Now we have to compare this with this. So how are we going to compare? So let me write this 1 into 99 and then 2 into 98 and then 3 into 97 and so on and so forth. Now what do you see here? You see that this number 1 can be easily represented using the number 50, and so is this number 99. Right? Now if I have 50 here, clearly 50 added up with, say, a quantity that has to produce for 99. So what exactly will that quantity be? So if I add 250, 49, I get 99. Now to the same 50, if I subtract 49, I would get this 1. Now let me move on to the next term. Now similarly to this 50, if I add 48, I get 98. To this 50, if I subtract 2, not 2, subtract 48. If I subtract 48, I get this 2. Now go back, or I would say go further. To 50, if I add 47, I get 97. To the 50, if I subtract 47, I get 3. Now clearly you can see that this pattern is going to be repeating all along until we reach all of the 99 terms. Okay, now let me go up over here and represent this. Now this is of the form a negative b multiplied with a positive b, right? So this is going to give me a squared negative b squared. So this is nothing but 50 squared negative 49 squared. And what is this? This is 50 squared negative 48 squared. And what is this? This is 50 squared negative 47 squared. Now from 50 squared you are taking away something, right? Some square. Now definitely when you perform that, the term that you're going to be getting will be strictly lesser than 50 squared. Similarly, from 50 squared, you are taking away your term. The output that you're going to be getting will be strictly lesser than 50 squared. And this is going to be the approach you will find for all the 49 couples that you have here. So this entire quantity, all of these quantities, each one of these quantities is going to be less than 50 squared. Each of this is going to be less than 50 squared. This is going to be less than 50 squared, this is going to be less than 50 squared, this is going to be less than 50 squared, so on and so forth, up until the 49th term couple. It's going to be less than 50 squared. All of these are going to be less than 50 squared, and then no matter you multiply it on both sides, 50 definitely, multiplying with 50 is not going to change the magnitude of these numbers. So in short, the conclusion is 50 raised to the power of 99 is greater than 99 factorial. So that brings us to the end of this solution beautiful problem. Please like, share and comment and express your alternate techniques or methods that you have. Until we meet again, thank you everybody.